The Roobot consists of two units. The upper unit is a 4x4 basic aluminum frame made from 1/4-inch plate. It rides on 4 custom-made zero-throw casters, each of which has a capacity of 240 pounds. The upper unit is connected to the lower unit by a piece of 1-inch diameter round aluminum tubing. This provides an opening for running wiring to electrical devices on top of the unit that can be connected to the unit's battery packs, provided there is enough cable to ensure that it's not twisted to the point of shearing. The lower unit clamps onto the upper unit's pivot points with a flange-mounted pillow block. This allows the lower unit to pivot independent of the upper unit while remaining connected. The lower unit is a 3-foot 10-inch diameter circle, again made from 1/4-inch aluminum plate. The lower unit is also supported on its outer rim by UHMW idler rollers. The drive systems, encoders, batteries, and electronics are all housed in this lower unit. The drive systems utilize 3 amp flow motor and gear reducers that are specifically designed for heavyweight robots. 2 of these motor assemblies function as a differential drive to move the unit across the floor, while the third functions as a tire drive on the underside of the upper unit's aluminum plate lid. The lid of the lower unit is pierced in several locations to allow for the drive wheel, the 3 idler wheels, and the revolve encoder to press against the upper unit. The drive wheels are 3-inch diameter keyed wheels on 3/4-inch shaft. The shaft is mounted on 2 flanged bearings that are epoxied into pieces of 1/4-inch aluminum plate. The drive shaft is coupled to the gear reducer via roller chain and sprockets. The encoders for this system are all held by custom-made UHMW armatures and are fitted with 3-inch diameter foam rubber wheels. The armatures are attached to the lower unit with torsion springs, so that the arms are allowed to translate up and down while still maintaining solid contact with the floor. This ensures that even if a motor slips on the floor, the encoder keeps accurate positioning and speed data feeding to the drivers. All of these units are powered by 6 12-volt 22 amp hour sealed lead acid batteries mounted to the underside of the lower unit. The battery terminals are all connected to serial buses. These buses are connected to a charging tail that velcros underneath the unit while it's running, but can easily be retrieved to plug in when it's time to charge. The batteries and motor drivers are held in place by industrial velcro straps that slip through welded-on brackets. The entire unit has a roughly 1,000 pound capacity, an anticipated 4 feet per second top speed, and is less than 4 1/4 inches in profile. In this sequence, we show a course that was designed to test the Roobot's maneuverability. The course begins with a graceful 90-degree turn. Now the Roobot will perform a tight 180-degree turn. And lastly, the Roobot performs a 0.90-degree turn. As you can see, this test was performed on our shop floor, which is chipped and covered in paint. Although the surface is uneven, the Roobot performed all of the maneuvers with ease. As you can see, we set up wooden pylons on either side of the course. These pylons were meant to represent and simulate the tight restrictions the robot might face while navigating a stage set.
So running on a concrete floor and at about half of what its overall speed is capable of, we're getting about 75, 76 decibels at about a meter away.
This test was designed to evaluate the robot's ability to track its center point while performing a zero-point turn. To perform this test, we placed a Sharpie marker down the center pivot point and performed a zero-point turn a full 360 degrees with the robot.
Stops on the dime.
It stopped.
This final test was designed to show the functionality of the unit's turntable. As you can see, the robot is not only capable of spinning its upper unit around the lower unit, it's capable of tracking in a complex pattern while doing so. Although difficult to control due to the fact that the operator cannot predict trajectory based on the unit's orientation, the effect, however, is impressive and the robot performs it flawlessly. Here we go.
And show us all falling over.